All right, so today we're going to cover LAB02, which is the trial head. So this is a hip replacement part. A couple things to know, or important things to know, is this stuff down here. So know what it's talking about with the 0.312 diameter times the 0.56 depth. And we have a 0.156 diameter through hole. We have a 3/8 16 TPI UNC 2B, and that's going down 0.37 inches in depth. And we have a countersink that's 0.44 inches by 90 degrees. So we have a couple of holes here. We have some threads. We have countersinks. We have a bore. We've got a couple of holes here. One's a through hole. One is a threaded hole that has some clearance down here. So we need to know what this information is telling us. So let's go ahead and get started. So you'll need to open up NX, make sure that you've changed your role to advanced, and we're going to open up a new part file. We want a model. We want to be in inches, and we want to name this LAB02 underscore your UUID, and make sure that we're saving this in a location that we can access. So to start off, what we're going to do is we are going to start off with a sketch, just like a lot of our models are going to be. We're going to start with a sketch. Now remember, we get to choose the plane that we want our sketch to be in, because we're going to create 2D geometry here, and then we are going to create our 3D objects from that 2D geometry. So we're drawing in 2 dimensions right now, and then we're going to add that 3rd dimension in our next step. I'm going to create my drawing in the on the right plane. So whenever we start our model, so before we even model anything, we're looking at a drawing, we're going from a drawing to a model, we need to be able to visualize what the shape is, what it looks like, and we also need to look at the views that we have. We're given these views for a reason. The person who made them, if they made the drawing correctly, they put the views on there that are most descriptive, that give a good idea of what the model is. So we want to take what we're given and go from there. So we have this side view where we have the holes. We can see the holes. And then we have this front view that we just see the cylinders, or we just see the round parts that we can't really see here. So we only have 2 views that we can really go from. And like, there's lots of ways to model this. We want to go for the most efficient way. So we're given a lot of information here. So we're actually going to start the sketch from this view. And our game plan here, we should always have a game plan before we start to model this, is we're going to draw only half of this, and then we're going to revolve it around this axis. So instead of extruding anything, we're going to revolve this 360 degrees around the axis that goes through the part. Since this is round, it's symmetrical, it's going to be the easiest and quickest way. So we're told that the largest part of this, so the largest circle, is 1.291 inches in diameter. And then we're given dimensions for this little chamfer here. It's 44 degrees from the center axis. And we're also given the dimensions up here as well. So the first thing I'm going to do is I'm going to draw a circle. Make sure that we're at the origin. And I want this circle to be the 1.291. And we're going to sort of draw that chamfer. So I'm going to come up here to profile. And I want to just Just kind of draw it. And then I'm going to go, so ideally we'd be on this line. I'm going to go past this line just a little bit across that horizontal line. And I'm going to hit escape to cancel out of that line. And I'm going to draw a line that just splits this circle in half. So I'm going to start from over here, and I'm just going to go all the way through. Hit cancel again to exit out of that. And this looks really weird. Like, what am I even doing here? Sometimes it's easier to draw lines like this where it goes past the point where we want to go, and then go up to trim or corner, depending on what you're doing. Corner works well too. Trim, and then we trim off the excess that we don't need. I'm also going to trim off this half of the circle. I'm going to trim this line where that chamfer kind of ends. And then I'm going to also take away the rest of those as well. And that's all the trimming that we need to do. Now we can start to look at some of these dimensions. Now we already have the larger circle dimension, that 1.291. And we also got it centered on the origin. So that's done. The larger diameter is done. Let's look at the other values that were given. We know that from the edge of the part to where that chamfer ends is 0.203. I'm going to hit from this line, and I'm going to try to get this point at the very top. We were told that is 0.203. And we also know from the center of the circle, so from the center of this, the 1.291 circle to the edge of the part is 0.364. So I'm going to go from the origin to this edge is 0.364. Now we also need to know what angle is this chamfer at. And we're told that it's 44 degrees all around. And go from there to the horizontal axis is 44 degrees. And we're to dimension from two parts. I'm clicking on that line and then just clicking on that line. Once you click on the line, you might get some dimensions at first. That's okay. You didn't do anything wrong. Just click on the other line if you're trying to dimension from one to the other. Our sketch is fully defined. So we can finish. And like I said, we're going to revolve this. So with the sketch still selected, I'm going to come up to revolve. And so my curves have already been selected because I had that sketch selected before it even hit revolve. If I didn't, then when I go to revolve, I need to either click on the sketches in my part navigator or click on the lines in the actual model. Either way, 4 lines have been selected. That's good. And then on the axis, I'm going to click specify vector. When that happens, these purple arrows are going to pop up. Remember, a vector is just a direction. So it's asking for a direction and a starting point, essentially. We can choose one of these arrows for the vector and then choose a point that we want that to be our origin, essentially, of the revolve. Or we can select one of the axes from our datum coordinate system. So I'll do it with this way. So I'm going to choose the y-axis, and then the point that I want is going to be this edge there. And boom, we have our trial head. Or do this again. Specify vector, or we could just specify this axis or this line. So if I just click on that line, it revolves. Or if I click on the axis, it's going to revolve as well. There's lots of ways to do it. Sometimes one situation it calls for something, and sometimes all three of the options will work. As long as you get this to revolve, you're fine. Make sure to do revolving 360 degrees, and our Boolean is none. We want to create a new 3D object. So we'll hit OK. And that looks about right. So now we need to do our holes in our chamfers and threads and all this good stuff here. So we're being told a lot of information here. So we have a 0.312 diameter hole that goes 0.56 inches deep. So that's this one here. We have a 0.156 diameter through hole. That's clearly the hole that goes all the way through. We have a 3/8. That's the diameter. That's the nominal diameter. A 16 TPI. So there's 16 threads per inch. UNC 2B. That's the class, and telling us whether we have internal or external threads. And we're being told that those are the threads are going down 0.37 inches in depth. So that's going to be this box right here. This dotted line that represents where our threads are at. I have a countersink that's at 0.44 inches in diameter at 90 degrees. So that 90 degrees is from this line to this line. Okay. NX does it from the center to the edge. So it's not going to be 90 degrees for us. We're actually going to put in 45 degrees because we want from this center axis here to the edge. So we're going to put in 45, but actually it's 90. It's just a different way of specifying what that angle is. And then we have a chamfer callout over here at 20 thou. Before I forget, so this 0.858, this is reference geometry. You never create geometry based off of reference geometry. This is just a check, just sort of like a note. So this is, someone might look at this to check to make sure that this is correct, but we never use this to actually define the boundaries of our sketches. If it's in a parentheses, you can't use it. Use this other geometry. There's a reason that this is a reference geometry. So let's go ahead and start making these holes. So remember I said we have a couple holes. So we're actually going to use 2 hole commands here. Now hole commands are extremely handy because they give us access. It gives us access to a ton of stuff. So the first thing that we're going to do is just going to do a simple hole. Our simple hole is 0.156 inches in diameter. Even though we have a chamfer on our drawing, we're not going to do it here. Because we have this rounded bottom right here, we're actually going to do it with a separate chamfer command up here. We need to specify our point. Now we haven't gone in and put a point in here, but what we can do is we can use the center of this circle right here. So you can see how as I approach this circle, the outside perimeter of the circle, we have a snap. So it snaps to that center. So that's what I want to do. I want to snap to that center circle. This is a through hole, but we don't want to just put in a value that is going to go all the way through the hole. What we want to do is we want to tell NX that this is a through hole, so that no matter what size this is, it's always going to go through the entire shape. So under limit, we've got depth limit, hole depth. The depth limit we want to change to, instead of a value, we want to change that to a through body. And so that you can see that it cut that off down there. It's just going all the way through, and then that's it. Make sure that we're subtracting, and we'll hit apply because we need to make another hole. Our hole should look like that right now. So the next one that we need to do is the threaded hole. we are actually going to do the chamfer, this 0.312 hole, and then also the threads as well, the 3/8/16 DPI. We're going to do all that in one operation. So we're going to here, instead of simple, we want to go to threaded. And our threads that are called out are, it's a UNC, it's a unified course. There are a lot of options here for the thread types. And just because we are in inches right now does not mean that we cannot put in a metric thread. If we wanted to put in a metric thread, we could do that. But we are in unified course, UNC. And we're going to choose a 3/8/16 TPI. 3/8/16. So the radial engagement can be either the 0.75 or the 0.5. But because we have that 0.312, that's telling us our tap drill size. And that's really what decides what our radial engagement is what's our tap drill diameter. You can see that when you change the 0.75, we get 0.3125. We change that to 0.5. Now we have a 0.3346 inch diameter drill diameter. We want a custom because we want to specify what our tap drill diameter is. And we're told that it's a 0.312. That's what that is telling us right here. It's a 0.312 diameter tap drill. We're using it to tap our 3/8/16 UNC. The tap drill goes down 0.56. NX, it's a little funky. You would expect that we got a tap drill diameter right here. The next thing should be what's the depth. But the depth of the tap drill diameter is going to be actual hole depth. So we're not going to address that yet. We're going to move on to our thread depth type. We can choose, 1 times the diameter, 2 times the diameter, or we can put in our custom or a full. So if we want threads to be going through the entire hole that we've made, we're going to select full. If there's a certain distance, we're going to put that in. So the thread depth type that we want is custom. And the depth we want is called out in the drawing. That is the, we're told that we've got a 3/8/16 UNC, and it's 0.375 inches in depth. So that's where we're going to put our 0.375, 0.3, or just 0.37, sorry. So those threads are only going down 0.37 inches into the hole. We'll put in our start chamfer. Now remember, this is where they tell us that it's a 90-degree angle, but that's going from one end of the hole to the other. But NX reads this angle from the center axis of the hole to one side. So the 90 degrees that's called out on the working drawing is actually 45 degrees according to NX. The diameter is still the same. It's still 0.44. Specify position. This is something new that we haven't done. So specify the position. Again, we just want to pick a point, and we're going to do it the same way that we did the first hole because it's the same center position. When we do this, though, it's going to give us a little warning, and it's going to say unable to find face of target body for direction. If you come down here to direction, we have normal to face selected. So what it does is we select the point, and then the direction that it chooses is normal to the face. So this face is right here. It's going to go perpendicular to that face. So whenever we select this point, it goes, okay, there's a face right here. I'm going to direct it either going down or going up. But we've selected this point, and it's kind of just there in space. It's not connected to any body because we've put that hole in there. So it doesn't know what direction to go in. And we're going to tell it which direction. So instead of normal to face, we're going to say along vector. And what we want to do is just select the inside of this hole. I find it easiest to do the 3 points and then make sure that we have the face of the hole selected. And it should find that vector. and orient itself correctly into the hole. Now the limit here, this is where we want to change that to a value, and we want this to be that 0.56. And this is why it's important to understand what's going on in this information here, because it's not just, copy and paste directly. This information does go in, but the order that you put it in is important. So we'll show our results real quick just to make sure that thing looks right, which it does. So I'll hit OK. And then we also need to put the chamfer in on this side. So we can go up to the chamfer command. This is a 20 thou chamfer, so 0.02. And then I'm just going to click on the edge of that through hole, the other side of it. If we wanted to get a better view of the holes that were created, you can't really tell. Kind of, it looks right, but I'm not exactly sure. Where we can go to View, Edit Section. And we can see our hole better. And this looks right, but we can't really see our holes, or we can't really see our threads. There's a couple ways that we can do that. We can go to Style, Static Wireframe. And these dotted lines are going to be our holes, or these dotted lines are going to be our threads. We could also go back to shaded and change our transparency. And we can see our threads that are created. Turn that on and off, or at least the section view on and off, just clip section. And make sure that we have all fully defined sketches. And that's it for this one. Make sure that you save that under the correct name and submit it to the Dropbox on Canvas.